Now we're going to show the PID adjustment for a speed stabilized or speed curve test. The motor we're using free runs about 2400 RPM, so I'm going to put the high value set to its free run speed of 2400. During the test, the lowest speed that we're going to run the motor to is 1000 RPM. So I want to type in 1000 RPM into the low value. The dwell is the amount of time that the motor will stay at 1000 RPM and at its free run 2400. This adjustment routine will cycle back and forth between 2400 and 1000 RPM. This is a DC motor. We're programming it with a power supply at 10 volts. To start the procedure, we need to put something into the P control. So we enter in a value of 50 and then begin the test. Now, what is happening here is our blue line is cycling between 2400 and 1000 RPM. Our green line is showing the initial set point for the P term, and the red line is showing our system response. Now you can see that the red line is coming well down below the green line, so our initial gain setting is too great, so we need to lower this until we get the red line fairly close to the green line. So now we have our initial P setting. The scale is A, the value is 10. Now we go over to our I term and enter in a starting value of 50. And you'll see that the system response is bringing the motor down to 1000 RPM, but it's taking a couple of seconds to get there. So in order to speed up that response, we'll change our I scale to the next value, B. Now you can see that we are getting to our target much faster, but we have a fairly large amount of overshoot. So we want to bring that overshoot down some by adjusting the I term to a lower value. Okay, at this point we've decreased our I term to 35. We have a small amount of overshoot and it settles in nicely at our target speed of 1000 RPM. So our adjustments are set at proper values to continue on with our motor test.